So after you have finished the fast start activity, we can move on with this video. So first, wrapper classes. In general, what is it? Well, they have all these primitives, they being the creators of Java. They have these primitive classes, primitive things, which are necessary but not real useful. You can store numbers in them, or you can store a character in them, and that's pretty much it. You can include them in arrays, but you can't put them in ArrayList because ArrayLists need objects. So in order to get around a lot of that and allow these numbers to behave like objects and to kind of give them more superpowers, they created wrapper classes. And essentially a wrapper classes takes a primitive and turns it into an object. That is the most basic explanation of a wrapper class. It takes a primitive and turns it into an object. So here are two examples of the wrapper class. The first one is double. So they take a double primitive and turn it into a class. I hate the fact the way they name this. They just use the capital D. That's it. That's the change. So if you're using a capital D, it's a class. If you're using a lowercase d, it's a primitive. Why is this important? Well, in the AP exam free response, if you're writing an object that's supposed to be a wrapper class double and you use a lowercase d, they will subtract a point from the free response because you've just made a primitive. Now, if you use a lowercase d and you use the new constructor, you might get away with it, assuming, you know, they've put that into the rubric, but I wouldn't count on it. Essentially, the way they usually approach that is it has to be absolutely clear that you meant to create an object, and it's just a quote-unquote typo. If it's not clear that you meant to create an object, then they won't give it to you. So in other words, let's say you forgot the constructor or you screwed something else up, then yeah, they're not going to give you that point. The other one is integer. They spell out the word for the object, and they use a capital I. All of the wrapper classes are going to be capitals. All of them are going to be capitals. And essentially wraps a primitive object, or not object, primitive thing, into a class type so you can make objects. So here's how you use them. If I wanted to create a new integer, I would say integer, that's the type, give it a name, use the new command because I'm calling the constructor. The constructor has to have the same name as the class. We've seen this before. And all you're going to do is put it in an integer. That's it. That's all the constructor is going to accept, putting in an integer. Then we can use the compare to, because integer implements the comparable interface. So compare to still works. We can now compare those things. However, you can't use equals equals anymore when you're using an object. Equals equals is not going to work because equals equals is comparing references, not values. So when we're comparing integers that are objects, we have to use the dot equals. So you now get the advantage of being able to use the compare to method, which will tell you in sort order where they are. Reiterate how this reads. N1 is where compared to N2. So N1 would be 45, so it's to the left of 56, which means you're going to get a negative result for this, less than 0. So N1 is to the left of N2. If you wanted to see if they were equal, you could see it, check to see, and use the compare to see if it's equal to 0. If you want to check they were equal just and only look to see if they were equal and use a Boolean operator, you'd have to use dot equals, not equals equals, because they're objects. They're not primitives anymore. So here is the Java doc for class integer, you can see that it extends number. So there is some class that we've never talked about called number that integer and double all belong to. We don't need to worry about the class number. It's not something we're going to talk about. It's not something on the AP exam. But be aware that number is more than likely an abstract class, and it's forcing us to implement some certain abstract methods. In addition, we're using the comparable interface and then something else called serializable, some other interface that we have to worry about. We're not writing code for this, so we don't have to worry about any of this. Somebody else already wrote all these methods for us. So let's take a look at what we can do. Well, first off, we have some definite constants. We have max value, min value, size, the number of bits used to represent an int in 2's complement binary form. And we have type, the class instance representative of the primitive type int. So those are static values and then a static type. Our constructors, now this is interesting. Our constructor can either take an int or a string, but the string has to represent some number. So if you have quotes, 56 quotes, you can use that as part of the constructor for an integer. That's cool. You can now convert strings to numbers very easily, just using an integer object when you build it with the constructor. Then we have all these different methods. Compare to, we have to know. Double value is nice because it returns the value of this integer as a double. Dot equals, we have to know. Float value is nice because it returns the value of this as a float. Get integer determines the integer value of the system property with a specified name, so it'll take a string. We can see that we have more parameters for that. That's definitely overloaded because there's definitely 3 sets of it. Hash code, don't worry about that. But it's definitely useful if you're talking about decoding stuff. Int value, long value, lowest 1-bit, number of leading zeros. So, I mean, you can see all of the different types of things that we can do with an integer now that we couldn't do before. We now have a much more powerful thing. The double, the float wrapper class, they all have similar methods. So if I create this in memory, remember the way this works. If it's a primitive and it's tied to the letter A, the variable A, then the 5, let's say it's a number that we're storing there, 5, gets stored right inside the memory location where A is. If it's an integer object, then what gets stored in that box is the memory reference to the value, to the object. Remember, that object now has a whole lot more power, so it requires a lot more memory, so all we're going to store is the reference. That's why we have to start using dot equals, not equals equals anymore, because when we're using dot equals, we're comparing to see if the objects are the same object, as opposed to comparing them to see if they are the same reference. If we use equals equals, we check to see if they're exactly the same reference, not the same memory location. The only useful part of that, using equals equals, would be to see if it's an alias. If you want to check to see if n1 is an alias of n2, you could check the equals equals, and that'll tell you if it's the same reference. And if it's the same reference, then our aliases of each other. So that might be useful. But it won't tell you and compare the values. All you can check to see is if they are exactly the same object. Like the same thing in memory has nothing to do with their value if you're using equals equals. You have to use dot equals in order to get the exact values. So we talked about the constructors. We have all of our methods. Lots of them. So these are some of the methods that are inherited from the object class itself. Again, not terribly important to us right this second. Here's an example. We have a primitive list here. This is an array. not an array list. It's an array. This was fine. We could populate it, but we couldn't do anything to it. We couldn't add anything to it. Finding the smallest element in this is challenging because we have to go through with a for loop, do some types of comparisons to find out the different values to check where was the smallest. So we'd have to do some interesting algorithm there to get that to work. We've done that algorithm before. It's not fun. But with a integer, well, actually, this is the example. Here you go. This is the solution. This is how you'd have to do this if it was in an array list. Excuse me, an array, not an array list. So you have to run a little for loop here, compare it to the integer.max value, check each one, set up a temporary value, and then finally return small. So it's not a simple thing to do. And there's 2 semicolons there. It should only be 1. So if we were to do this with an array list, we could take advantage of the ArrayList functions and take advantage of the fact that an integer is now an object that can be stored on an array list. And we could just use the ArrayList functions and just sort the array list. Once the array list is sorted, all we need to do is take the first value. Much simpler. Instead of having to go through this complicated thing, if it was the ability to be an array list, we would just sort it. And once it's sorted, all we have to do is take the first value. Like 2 commands rather than this. So it does give us a lot more power once we start treating it as an object. There is a wrapper class for a double. Here's our constructor. You could create an array list with it, like I was saying. But you do have to declare the type. That's good style. Unless you're going to you're going to have multiple different types in the array list, always declare the type that's going in the array list. And like I said, I always like to put it in both spots, just in case I forget which side it really has to go on. I always put it in both. So I put it here, and then I put it here, always after the array list word. So it's array list declaration of the type. Okay, it makes it easy to remember if you're just consistent and do that all the time. So in code, this is what it would look like. We have our constructor for n1 of type double. We use our new command to construct a new object. Our constructor called double. It's taking an int. It could take a string as well, but it's taking an int in this case. We're creating an array list called h of the type double. Remember, we couldn't do this with a primitive, so if you tried this with a lowercase d, it would not work. And then we can use the h.add and just add that item to our array list, add our number in. And then we can add in new doubles if we wanted to. This is a nice little line of code here. You don't have to assign it to a variable. We could just assign it to a spot in the array list. So h.add and say new double. Just call the constructor. And then finally, they're printing out h, which we saw has a nice effect because it has a toString, and it just prints out all the values in a nice formatted list for us. Again, not something we could do with an array, because an array you'd have to have a for loop, you'd have to know the length of the list, and then you have to do an individual print statement for every single one, you'd have to add in commas. It's definitely a pain in the neck if you're using an array. Here's another example where we're adding in 2 different numbers and printing it out. Using the remove feature, we can remove individual values of the array list. So array lists and doubles, the practice is going to probably go a lot with that because you're talking about array lists and doubles together. And that's basically it for wrapper classes. There's not a whole lot. It's just talking about the idea that you're putting a primitive inside of an object. And you now have access to all these different methods. So there is an exit ticket, but there is no practice for this because there's really not much to practice. It's just knowing that there's this thing now called an integer that you now have access to. It's designed to make your life easier. So when we get to the unit assignment, you might want to use some of your wrapper classes in order to do that project. Don't forget that you have them. They will make your life easier. So instead of thinking of an array, think of an array list. and think of using objects rather than using primitives. So that's it. We have one more lesson left in this unit, and then a quiz and a project, or a test, I should say, and a project. And then we have one more unit left, Unit 7, which is a review of algorithms, and our AP review. Okay? So, never stop coding.